Hi class, it's Mrs. Johnson here. This week we are going to move on to a new chapter in discussing the concept of polynomials. Some of those exponent rules that we have discussed over the last few weeks in our lessons are going to come into play in this chapter. And we're going to go through essentially each operation. We're going to learn how to add, subtract, multiply, and divide polynomials along the way. In this first set of notes that we're going to cover here today, this is just an introduction. I'm introducing you to the concept of polynomials and where some of these words come from that you will hear us use over the course of the next 2 or 3 weeks on our chapter in polynomials. So hopefully you have opened the polynomial number 1 handout, as that is what I'm going to be going over here with you. And if you could fill that in as you watch the video, hopefully you will gain some understanding as to where the degree and number of terms names come from in learning about polynomials. So the definition, what is it? In terms of a polynomial, it is an expression consisting of many terms. And those terms could be a variable, they could be a number multiplied by a variable, they could be a number multiplied by a variable with an exponent. There's a lot of options we have when we talk about terms. Now, we are asking that every time you write your answer to a polynomial, your answer will be written in standard form. There are 2 criteria for this. The first thing is that it must be written in alphabetical order, which means if you have multiple variables, obviously A would come before B and so on. So, alphabetical order. The second criteria is probably more important than the alphabetical order, and that is that we want the highest exponents first. So if we have a 3, a 2, a 1, and then a constant term, obviously that would be written in standard form. So the highest exponent is called the degree. And if you look at this example that's given here, you can see it's written in standard form. You have a degree of 3, 2, and then there's technically a 1 here, and when there's no variable, technically the exponent would be a 0. So as you notice, you have 3, 2, 1, 0 in decreasing order. You do not write the 1, you do not write the 0. That would be technically incorrect. So without seeing the 1 and the 0, you can know that they do exist there. Okay. So you have 2 concepts in this lesson today. The first one is classifying polynomials. As we classify them, they're classified by 2 things. Number 1, their degree, which is actually the exponent, the highest exponent, and the terms, which is how many pieces there are that make up the polynomial. So we're going to have 2 words as we classify these things by degree and number of terms. Now in this first one, you notice there is no variable. So that means that there is 0 degree. The degree is considered a constant. And there is only the number 6. That's 1 term. So if you look at your chart, the number of terms, if there is 1, that is considered a monomial. So you are picking the 2 words from the tables given that classify each one of these polynomials given. Now in number 2, there is a variable, and even though there's not a degree here, we assume there's a 1 after that x. So if you look here, if the degree is 1, linear would be the degree classification, and there's still only 1 term. Both of those things are together, so it's classified again as a monomial. Mono means 1, binomial 2, trinomial 3, and then 4 more would be a polynomial. In number 3, again, the highest degree here is a 1. Right after that x, you would have a 1. So the degree classification is linear. But notice there is actually 2 terms. So 2 terms would classify this as a binomial. In number 4, we finally have an exponent that's written, so 2 is the degree. If you look at your chart, 2 is considered quadratic. And if you look at how many terms, we have 1, 2, 3 terms, which is considered a trinomial. For number 5, the degree is 3. So 3, based on the chart, is cubic. And there are a total of 2 terms, which would be a binomial. In number 6, 4 is the highest exponent. So based on our chart here, 4 is considered quartic. Beyond 4, we really don't have a special name for the degree at that point. But if you do notice, beyond 4 terms, this is automatically considered a polynomial. Poly meaning many, so there are many terms that make up this expression. So that's the classification portion of our intro on polynomials. You should have 2 names, one for the degree, one for the number of terms. So these 2 charts, you don't have to have them memorized, but it is something good to be familiar with and something I would consider referring back to anytime your questions are asking for this classification. Now, at the bottom here, you're asked to write the polynomials in standard form. So based on the beginning definition, standard form has 2 rules. It has to be in alphabetical order with the highest exponents first. So for number 7, you can see there's an exponent of 2. That's our first or highest exponent, so that will be the first term we write in our standard form. Then the 3x would have a 1, so that would go second, and then our constant or the number will go at the very end. Notice that I'm taking any sign that is in front of the term, and that is carried along with the term as you write it in order. So in number 8, we have 7x to the third. That will come first, plus x squared minus x plus 64. In number 9, now this one, you notice the 3 and the 2 are already in order, so you will keep x to the third, 5x to the second, but your x and 28 will need to switch. Minus x, that has a degree of 1, and those constant numbers always come at the end. For number 10, you have negative x to the third plus x plus 24. Notice again, the negatives in front of the x to the third, positive, and 24 is positive, so I kept that with a plus sign. The last 2 questions are where the alphabetical order concept comes into play. So you start with any term that has an a. So I see a to the third is the highest exponent with the letter a. So a to the third will come first. Then I have a term that has an a squared. So you continue to write down all of the terms with a's first. There's a third term with a, and that is 2ab. And anything with just a b will go at the end of the polynomial. Okay, the last one, you have x and y as your 2 letters. So in the alphabet, x would come before y. So I have a negative x to the third. That's my highest exponent. I have a negative 7x squared y squared, my second highest exponent. Then I have just a letter y. So that will come as the third term, and always the last part of your expression. If you have any constants, which are just numbers, that would be the last and final piece to your polynomial. So hopefully this made sense as you've watched the video. If you have any questions, as always, please feel free to reach out, and I hope you are all doing well. Thank you.